Hello everyone, myself Deepali Koshta from Dr. Hari Singh Bosch Central University, and my presentation is based on the topic electron transport chain. So first of all, I will give you introduction about what is ETC, what are the components of ETC, where is ETC located, and the last stage of ETC. So let's begin. Introduction. An electron transport chain is a series of proteins where protein donor transfer electron to protein acceptor, and this transfer of electron leads to the formation of ATP. This creates an electrochemical gradient that derives the synthesis of ATP, a molecule that stores energy chemically in the form of highly strained bonds. The molecules of the chain include peptides, enzymes, etc. The final acceptor of electrons in the electron transport chain is molecular oxygen during aerobic respiration. ATC is the fourth and final stage of aerobic respiration. ATC is a series of highly organized oxidation reduction enzymes. The reduction of energy flow level in the ATC is in the form of higher pure energy level. What is ATC? ATC is a process in which NADH and FADH2 produced during glycolysis beta oxidize, thus releasing energy in the form of ATP. The metabolic pathway through which electron passes from one carrier to another is called as electron transport chain. The following steps in the respiratory process are to release and utilize the energy stored in NADH plus and FADH2. This is accomplished when they are oxidized through the electron transport system and the electrons are passed on to the O2, resulting in the formation of H2. Now we will discuss about where is ETC located. The ETC is located in the inner mitochondrial membrane, as you can see in the diagram that I will stick here. Protons are transported from the matrix of the mitochondria across the inner mitochondrial membrane to the inner membrane space located between the inner and outer mitochondrial membrane. The process takes place in the units arranged on the crusty membrane of mitochondria. What are the components of ETC? The various components of the respiratory chain occur within the mitochondria. Complexes are formed by proteins itself. Each of the four complexes contain up to 40 individual polypeptide chains. They perform several functions such as enzymatic activities and transmembrane forms. The large transmembrane complexes are called as complex 1, complex 2, complex 3, and complex 4. There are four complexes used in the electron transport chain. That is, first is complex 1 NADH dehydrogenase, complex 2 succinate dehydrogenase, complex 3 cytochrome BC1 complex, complex 4 cytochrome C oxidase. So now we will discuss about briefly complex 1 NADH dehydrogenase. There are four steps in the citric acid cycle in which hydrogen is taken up by NADH to form NADH. Electrons from NADH produced in the mitochondrial matrix during citric acid cycle are oxidized by an NADH dehydrogenase complex 1, which contain tightly bound covectors FMN and iron sulfur centers. The electron passes to the next carrier coenzyme Q of ubiquinone. Complex 2 succinate dehydrogenase. Succinic acid is the only substance in the citric acid cycle which is oxidized by 2 to form FADH2. Ubiquinone also receives reducing equivalent via FADH2 complex 2 that is generated during oxidation of succinate in the citric acid cycle. Complex 3 cytochrome BC1 complex. The reduced ubiquinone is then oxidized with the transfer of electron to cytochrome C via cytochrome BC1 complex. Cytochrome C is a small protein attached to the outer surface of the inner membrane and acts as a mobile carrier for transfer of electron between complex 3 and complex 4. 4 protons are out for every 2 electron transfer to the next carrier. Complex 4 cytochrome C oxidase. It refers to cytochrome 3 oxidase complex containing cytochrome 8, cytochrome A3, and 2 copper centers. The cytochrome to oxygen, which takes a proton to form 2 molecules of H2. The complex is known as terminal oxidase. For transfer of 2 electron to proton are formed into the intermembrane space. And finally, the last stage of ETC. The protons are then moved to the outside of the membrane. At the end of the ETC, the electrons are given to oxygen at the same time oxygen accepts hydrogen from water. Now we can see the process here. Half O2 plus 2H plus 2 electron. Then the water is formed. Oxidation of one molecule of NADH gives rise to 3 molecules of ATP, while oxidation of one molecule of APTH2 gives rise to 2 molecules of ATP. The energy released during the electron transport system is utilized in synthesizing ATP with the help of ATPase complex 5. This complex consists of two major components F1 and F0. The F1 headpiece is a peripheral membrane protein complex and contains the site for synthesis of ATP from ADP and an organic phosphate. F0 is an integral membrane protein complex that forms a channel through which protons cross the inner membranes. The passage of protons through the channel is coupled to the catalytic site of the F1 component in the production of ATP. For each ATP produced, 2 hydrogen passes through F0 from the intermembrane space to the matrix down the electrochemical proton gradient. References: Plant Physiology, NCERT, Wikipedia, YouTube at ease. Thank you.